six, hold, six, hold, six, hold, six, hold, six, hold, six, six, hold, six, hold, six, six, six,
check, test hall, check, test hall, check, hall, check, test hall.
Students, kindly maintain silence. The live link, YouTube link, will be shared in the class group. So if at all you have your friends or anybody you want to share with, please share the link. Please maintain silence.
Hall. Check. Hall.
Hello.
Hello? What you sent is WebEx ka link, no?
ಯೂಟ್ಯೂಬ್ ಉಂಟಾ ಸರ್ ಯೂಟ್ಯೂಬಲ್ಲಿ ಲೈವ್
That
ಇದೆ
is, I think, for the second keynote speaker, no?
ಸರ್ ಯೂಟ್ಯೂಬಲ್ಲಿ ಲೈವ್ ಇದೆ ಆ ಲಿಂಕ್ ಕೊಟ್ಟಿದ್ದೀರಾ ಯಾರಿಗೆ ಕೊಟ್ಟಿದ್ದೀರಾ ಫ್ಲೆಬಿಟಾ ಲಿಂಕ್ ಇದೆ ಫ್ಲೆಬಿಟಾ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಇದೆ
But they have to send it before the program starts.
HOD ಕೊಟ್ಟಿದ್ದಾರೆ ಹೌದಾ
Where is the YouTube link?
ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಎಲ್ಲಿದೆ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ he gave to you it seems
Send it in all the class groups.
hey ma'am where it is not on welcome
Cletus, can you check if that mic is on?
ಅದು ಡಿಸ್ಪ್ಲೇ
A display.
ಸರ್ ನೀವು ನಮಗೆಲ್ಲ ಪಾಸ್ ಮಾಡಿ
That I'll announce.
Hello, Mike.
Send it to the students group.
Hello, mic check. Hello. Yes.
Chip is not doing that these people are only doing
Students, please note the YouTube link has come. Please click and see if it's opening. Please watch it. Internet is there. Please use your data and check if you're not getting the Wi-Fi. Please open the link and check if it is opening. Anybody who's opening, checked. Not opening? Hey, it's not opening, it seems.
ಪ್ರಿನ್ಸಿಪಾಲಿಗೆ ಮಾಡಿ ಅಲ್ಲಿ ಹೋಗಿ ಹೇಳಿ ಬರುತ್ತೆ
ಫೋನ್ ಮಾಡ್ತೀನಿ ಅಂತ ಅಲ್ಲಿ ಗೊತ್ತು ಐ ಟೋಲ್ಡ್ ವಿಲ್ ಕಾಲ್ ಅಂತ
Students, kindly pay attention. We are going to begin shortly. Please do not make noise during the session. Do not talk. Take your seat. Shaja, no, it's inside. It's inside. What happened? Take stress. Sati sir. Sati sir. Kindly maintain silence as the dignitaries have arrived. Kindly rise as the dignitaries have arrived. I request Dr. Surya Krishna, Head of the Department, Electronics and Communication Engineering, to escort the dignitaries onto the dais. Thank you, everyone. Kindly take your seat. Warm greetings this morning to each of you gathered here today. It is an honor for us at Srinivas Institute of Technology to welcome each of you to the inaugural program of the International Conference on Technology for Industry 4.0 Revolution. We are on the cusp of what has been termed as the fourth industrial revolution, conceptualizing rapid changes to technology patterns and processes in the 21st century, a transformation termed 4.0. The century is witnessing a gamut of cutting-edge technologies with a myriad of applications. To keep abreast with technology changes that are happening at a very fast pace today, the Electronics and Communication Engineering Department has taken this initiative to host ICTIR 2023. We are indeed honored to have the presence of distinguished academicians and luminaries with us today.
The world we build tomorrow is born in the prayers we say today. As we march forward with great hopes and aspirations, let us invoke the blessings of God Almighty. I invite Aishwarya, Electronics and Communication Engineering Department, to lead us in prayer. Kindly rise.
Pratamavandana Gauri Nandana Pratamavandana Gauri Nandana He Shivanandana Pahi Gajanana He Shivanandana Pahi Gajanana Pratamavandana Gauri Nandana Pratamavandana Gauri Nandana.
Thank you. Kindly be seated. An investment in knowledge always pays the best interest. It's an honor to have distinguished stalwarts in our midst, and we deeply appreciate your presence with us today. I invite Dr. Surya Krishna K, Head of the Department, Electronics and Communication Engineering, to welcome the august gathering and introduce our chief guest.
Respected Principal, HODs, my colleagues and students. it is my utmost pleasure to welcome you all for the second International Conference on Technology for Industry 4.0 Revolution, that is ICTIR 2023. The fourth industrial revolution is revolutionizing the way we live, look, and interact. It is characterized by the fusion of cutting-edge technologies such as artificial intelligence, Internet of Things, big data analysis, robotics, and automation. Our conference theme reflects our commitment to understand and harnessing the potential of these emerging technologies. On this occasion, I welcome our beloved principal, Dr. Srinivas Mayadi, president of today's function. Welcome you, sir. I welcome Mr. Prashant Kannadaguli, Senior Data Science Trainer, Dharini Academy, Bangalore, chief guest of today's function. Now I will read his brief biodata to introduce to the gathering. He completed his MTech from Manipal and MS from Germany. His research interests include language models, speech recognition, and deep learning. He worked as a senior R&D manager, NLP and speech recognition in Aurora, Bangalore. He worked as machine learning expert in IoT Academy, Noida. He started his own training institute, Dharini Academy, in 2016. Currently, he is the trainer on data science applications in IIT Guwahati, Python trainer at MIT MicroMasters Program, USA, senior data science faculty at Hero Wired, India, data science trainer in Haifa Mentor, USA, international training consultant for AI, ML, DL, and data science at Lithan, Singapore. He completed many certification programs and having more than 18 international publications in the field of NLP, speech, and computer vision. This is his brief biodata, and he is having many more accomplishments to his credit. Today, he is going to be with us and give the keynote talk on the machine learning process. I welcome you, sir, to this program. Another person with us in the online mode is Dr. Vivek PK from University of Technology and Applied Science, Sultanate of Oman. He is going to give the second keynote address on transforming distributed sensor networks with comprehensive sensing in online mode. His brief profile is, Dr. Vivek is working at the Electrical and Electronics School of Engineering, University of Technology and Applied Science, Sultanate of Oman. He has done his PhD in signal processing, MTech in VLSI and embedded systems, and BTech in electronics and communication engineering. He is having 17 years of teaching and research experience. He has published 17 papers and authored 2 books. His research areas include signal processing, sensor networks, and compressive sensing. I welcome in his absence for this program. Also, I welcome HODs of other departments, external participants, our own students to this inaugural program. Thank you.
Thank you, sir. Flowers ring in good cheer and add joy to our new beginnings. I now request Professor Rakesh Milya, Department of Electronics and Communication Engineering, to florally welcome the chief guest of today's inaugural function, Mr. Prashant Kannadaguli, Senior Data Scientist Trainer, Dharini Academy, Bangalore. Thank you, sir. I request Professor Cletus Neil D'Souza, Department of Electronics and Communication Engineering, to welcome the patron of this international conference, ICTIR 2023, Dr. Srinivasa Mayadi, Principal, Srinivas Institute of Technology, Mangalore. Thank you, sir. I request Professor Nagalakshmi, Department of Electronics and Communication Engineering, to welcome Dr. Surya Krishna K., Head of the Department, Electronics and Communication Engineering, Srinivas Institute of Technology. Thank you, ma'am. I request Professor Deeksha, Department of Electronics and Communication Engineering, to florally welcome the convener of ICTIR 2023, Professor Gaurish Hegde. Thank you, ma'am.
Where there is light, darkness cannot reign. Where knowledge has come, ignorance must quit, says the good old adage. A glowing light ushers in good tidings and is a forerunner of a new beginning. I request the dignitaries on the dais to light the lamp which is symbolic of the knowledge we disseminate. Kindly rise. Kindly rise.
कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय
Kindly
दीपज्योतिर्नमोऽस्तुते
rise.
कल्याणम् आरोग्यं धनसम्पदः ज्योतिर्परब्रह्म
Kindly rise. Using Android television.
Thank you. Education is the premise of progress in a society, and a happy life is one spent in learning and yearning for more knowledge. I now request the convener of the ICTIR 2023, Professor Gaurish Hegde, to read the conference briefing.
Hello. Good morning to all, respected dignitaries on and off the dais. The international conference can help students refine their skills and abilities. It aims to help students understand the basic skill set that will help them reach the pinnacle of success in short time. Time management, inventive thinking, cognitive reasoning, leadership, and digital literacy are some of the top skills taught in such events. The ultimate way to put your theory to the test and enrich your research is by exposing it to dynamic review and debate. Prestigious academic discussions can be the best platform to present your research and gather feedback. Also, conferences discuss the latest trends concerning particular topics. Conferences are a great medium to get acquainted with new trends, future plans, solutions, and how to adapt to them. Therefore, Department of Electronics and Communication Engineering is giving an opportunity to the students and research scholars by conducting an international conference on technology for Industry 4.0 revolution. This time, we have invited papers from latest topics such as IoT, robotics and automation, machine learning and deep learning, cloud computing, signal and image processing, 5G communication, advanced embedded system and VLSI, sensor technology, power management, security management, big data and blockchain, and product-based startup work. A total of 21 papers will be presented in the conference. I cordially invite all the enthusiasts to participate with full vigor in this celebrated event, which can give immense exposure and global opportunities to all. I wish all the participants good luck. Have a nice time. Thank you. Thank you, sir.
Thank you, sir. Today we are on the brink of an extraordinary revolution, an information age where content needs to be organized, processed, and available to the right people in the right way. I now request the president of today's function, Dr. Srinivas Mayadi, to release the book of abstracts. I request Professor Cletus to kindly assist in the same.
Thank you. Nothing is more powerful and liberating than knowledge. Today, we are entering a new phase of advances in technology which hold considerable potential to lift the trajectory of economic growth. May I now request the chief guest of today's function, Mr. Prashant Kannadaguli, Senior Data Scientist Trainer, Dharini Academy, Bangalore, to address the gathering.
Respected dignitaries on the dais and faculties of different departments, HODs, and dear students. We are having the international conference on one of the very important technology that is in the Industry 4.0. Considering the current trend where the industry is moving towards these days, this particular conference becomes one of very crucial in that aspect, because everywhere Industry 4.0 is concentrating on, it has several aspects like big data, the cloud computing, and the data science, machine learning, AI, building up of chatbots, and also robotic automation, cloud, etc. Considering that, I could just glance through the abstract book, and I could see that most of the papers that are going to be presented in this particular conference are student projects and working towards the same, so towards the same direction. So I highly appreciate that. So I wish best of luck for the presentations. I appreciate all the efforts made by different departments in organizing this, and I thank everyone for this opportunity for me to give a keynote address. Thank you, everyone. Thank you so much.
Thank you, sir. We look forward to hearing more from you. Wisdom is not a product of schooling, but a lifelong attempt to acquire it. Education is the most powerful weapon which you can use to change the world, as it helps us to move from darkness to light. It is the art of a leader to ignite the joy of learning within us. May I now request our principal, Dr. Srinivasa Mayadi, to enlighten us with your motivating words.
Good morning. I'm Mr. Prashant, Dr. Surya Krishna, Professor Gauri Shegde, my colleagues and paper presentators and dear students. As head of the department is already told, this is the second international conference is organized under Electronics Engineering Department. The topic is given a very interesting topic. I hope all of you agree for that. Technology for Industry 4.0. So it is started from 1.0, technology 1.0, then 2.0, 3.0, next is this is the 4.0. What is this 3.0? When the computer was introduced to the systems, that is the technology changes everywhere we can see. The same way now you can see that artificial intelligence, machine learning or data science changing the life of the people, lifestyle of the people. If you see that few of you already may be getting experience of that, but when we talk to in my chamber along with Mr. Prashant, he said that next 15 years, this technology going to have an impact to the society. As we are observing that every day, the technology changes. Okay, maybe Google gives all the informations to us, we started typing it. Now it's not required. To the Google, you just say that your mouth, I need this information, it gives. The same technology may be available in other forms also, like Alexa devices. You go and ask something in front of that, it searches all the informations throughout the world and gives. And like as a chat GPT, many things are coming by using the artificial intelligence. That as a foundations for all these changes, electronics also very, very important. So if the people understands that technology changes and what new technology comes, what is your contributions to this technology? That can be start from this type of international conferences. You are given the chance to publish your papers or present your papers so that you can share your ideas to other people. You may develop that further, or some other can take that as a clue and that they can able to develop further for their productions or to their research work. That is the reasons this type of conferences is playing very, very important role. So electronics departments arranged this type of conferences. So I request all the paper presentators use this as a platform and develop your research work so that automatically you are also one of the contributor to the Industry Revolutions 4.0. And you may become as a future leader in the technology. So we are invited to keynote speakers for this. One person is already here, the other person is coming on the online. Mr. Prashant is the right person. When I'm just talked maybe 5 minutes in my chamber, we found that he have a lot of informations about the technology 4.0. So he has trained many good institutions. Many are started their own industries, and many of them are working in one major industry on data science or artificial intelligence industries. So when we invited him here, he is readily accepted to come and inaugurate the international conference. We are very grateful to you, sir, for coming and going to give the good talk on data science for the next session. So with this, I would like to congratulate the electronics departments for organizing the second international conference. It is going to be helpful to our teachers, our students, as well as the paper presentators. So at the end of the 2 days, what you carry forward with this international conference, that's very important, and how you going to build or improve that in the future. That is very important. You are requested to carry something good from these international conferences. With this, I wish all of you a good day. Thank you.
Thank you, sir, for educating us with your thoughtful words. Gratitude and thankfulness cannot merely be expressed by words. May I now request President of today's function, Dr. Srinivasa Mayadi, Principal, SIT, to hand over a memento as a token of appreciation to our chief guest, Mr. Prashant Kannadaguli.
Henry Ford says, coming together is a beginning, keeping together is progress, and working together is success. It is indeed the joy of working together that has brought us where we are today, and soon we will be soaring to greater heights. But this end means the empowered beginning in our quest for knowledge. I request Professor Satish Kumar, EC Department, to render a note of gratitude.
Good morning, everyone, and thank you all for joining us today. Respected dignitaries on and off the dais, on behalf of Electronics and Communication Engineering Department and the organizing committee of International Conference, I, Satish Kumar K, stand before you to express my heartfelt gratitude and present vote of thanks. First and foremost, I would like to extend my deepest appreciation to our esteemed chief guest, Mr. Prashant Kannadaguli, Senior Data Science Trainer, Dharini Academy, Bangalore. Sir, your presence here today has added immense value to our gathering, and we are honored by your participation, sir. I would like to express our sincere gratitude to guest of honor, Dr. Vivek PK, University of Technology of Oman. A special word of thanks to our beloved principal, Dr. Srinivasa Mayadi, for his presidential address, encouragement, and constant support for organizing this event. Thank you, sir. At the outset, we would like to thank our college management, A. Shamarao Foundation, for their support to organize this event. Furthermore, I would like to acknowledge and thank Professor Gauri Shegde, Head of the department, Dr. Surya Krishna sir, who have worked tirelessly behind the scenes. Your enthusiasm and support have made this event run smoothly. Thank you, sir. Our heartfelt thanks also go to all the teaching members and non-teaching staff and also technical staff. Your presence and involvement made this gathering vibrant, dynamic, and enriching. In conclusion, I would like to once again extend my deepest gratitude to everyone who involved in making this event a resounding success. Thank you all for being part of this event. Have a wonderful day. Sarve Jana Sukhino Bhavantu.
Thank you, sir. With that, we draw a close of the inaugural function. I request the convener of the ICTIR, Professor Gaurish Hegde, to escort the dignitaries off the dais. We will now have the keynote address by our chief guest, Mr. Prashant Kannadaguli, Senior Data Scientist Trainer, Dharini Academy, Bangalore. And the topic is the machine learning process. Students, kindly be seated without making noise.
Hello.
Students, kindly maintain silence while the talk is on.
Good morning, everyone. So, the main question is about artificial intelligence. This is just because just now our professors mentioned that industry is moving all the way towards a particular direction in which all the industrial giants have access to huge data. So this huge data, in the sense, whenever you use any app, you see they start collecting your data set right away from the beginning. What's your mail ID? What's your phone number? And many other questions, right? So that's where everything has begun maybe 10 years back, when these tech giants like Facebook, of course Google, Apple, right, etc. Those companies started accessing the data. And right now, they have data set of last 20 years of almost every one of us. So that's actually, that's the starting point where the concept of big data came into picture. and in big data, they are trying to solve business problems based on the data set they have collected. So the data science is the big picture in which one of the very crucial topic is machine learning. So I'm going to the overview once again during the slides, but just to start this particular topic, I have chosen to discuss about what is the process in which the machine learning is going to be carried out. It can be industry or it can be research, where someone who is going to start their career or someone who wants to learn something specifically in the field of machine learning, what is the path? So we'll discuss about that. That's the basic idea here. So let's assume that we want to build a ML project. Basically, it starts like building a house. So if you want to build a house, we know that it actually starts from foundations, and you try to build walls, then concrete, then wrapping up the building with like what is the color you want, or what are the types of windows you want, etc. So that's the whole process, right? Let's try to discuss this whole process of machine learning in the same way like you are trying to build a house. So it starts with, say, the foundations. What are the foundations that are needed, right? So anyway, we are into the engineering education, definitely. We have been introduced into the foundations already. As you can see, one of the foundation topic is mathematics. So basically we want maths, and the second part is programming. Okay, so you have options whenever we start learning or start building our career in ML. It is expected that you need to know mathematics. So we know we have studied mathematics, one can say, but basically we want 4 aspects of mathematics. So one is the linear algebra. It's because machines can understand if you give the data set in a specific format, and that format is the matrices, right? You give any other format, it's hard for machines to understand. See, we are trying to make machines to understand about what data set I am giving. I am giving the input like cat, dog, table, chair. These are my data set, and you are teaching machine to identify, okay, this is how cat looks like, this is how dog looks like. If you are trying to teach them, you have to convey the information in such a way that machine can understand, analyze easily. So matrices is the first aspect. That's why I started with that. So in the foundational aspects of mathematics, one has to start learning the whole process with the linear algebra, concepts of linear algebra, right? It can also involve matrix multiplications, right? A decomposition of matrix into 3 different matrices, the LU decomposition, which you may be familiar with, like that. Okay, so those are that's the first step. Then we need calculus, because one of the very widely used calculus part is the differentiation, right? So the auto differentiation is one key aspect when it comes to the machine learning. Okay, so that's the second part, and then we'll move to the third part under mathematics. So any guess what you need? What could be the third? Probability, yes, absolutely, because everything is probabilistic, probability, and the fourth one is statistics. So those two go hand in hand, and most of the models that we build in ML, or the updated version of ML where we discuss and where we deal with the deep learning concepts, are probabilistic models. So you need to know how to calculate the probability of raining tomorrow if I give you 10 days of data set. Last 10 days you see, observe, and you make a prediction that there is a 70% chance of rain, right? So this stock price is going to rise tomorrow so that I can invest, right? So this is a probabilistic way. So probability plus statistics. Why statistics is required? There is a concept called as hypothesis analysis. You make a statement, this party is going to win this election, right? So you make a statement and you will make calculation and you will say that, okay, right? This is the chance of getting that statement being true or false. So like that. So those are the 4 fundamental parts coming to the mathematics, and then we have a programming. So it is left to us. Whoever is a learner or whoever is a developer can choose, but most widely used option is Python. You can also go for MATLAB You can select Java, C, C++ as per your requirement. But why Python is very famous? Because it's, first reason is it's free. Second reason is there is a lot of libraries available. So each individual application you want to build, there is a good support, right? You can get the libraries, you can download, you have a huge help available. Those are the reasons. But if we can afford, MATLAB is the second best option, all right? So that's the fundamental step, step number 1. Then we can see that the step number 2 over there is the ML. So we know the basics, we have the tools available, we built the foundations, now you need to build the walls, right? That's going to happen by learning different ML algorithms. So what are ML algorithms? We'll see that later. And ML is already implemented, industry is widely using ML. Now the research is trending towards DL, which is the next version, which is called as a deep learning. So there is a bridge between ML and DL. That is what we call as neural networks. And learning all the models, how the models works, what's the maths behind that, how do you do the coding of each of those aspects come under what is called as, okay, so that's what is going to happen over here, right? So we also deal with the data engineering. That is because I made an initial statement saying that everybody has access to the data set, right? So you will collect the data for sure, but there is a huge component called data engineering where I have the data, but what part of that data which I have collected should be used, because everything you collect, you cannot use it for ML or DL. Because machine learns only if you give a very specific data in a very specific format. It may be dependent on what hardware you use. Do you have CPU? Do you have GPU? Etc. Right? So it depends on that. So there is a component called data engineering which deals with refining your data. Right? It can be very simple as removing of noise. It may start from there, right? But it will go up to feature reduction, etc. Many components are there under this data engineering where you try to look at, you can perform something called as exploratory data analysis. You will do analysis, again statistics comes into picture over there. So this is the step number 2. All right, then the computation comes into picture. Whatever mathematics we have studied, right, as a basics of in the step number 1, you will be applying them over here. Okay, so that's the computational requirement for ML and DL. So once we are fine with that, then you can, then you learn the tools required for them, because I can say I know Python, right? I have learned as per the requirement number 1, I learned that. I can say I know the mathematics, but you need to use very specific tools to be utilized according to your requirement, right? So maybe you are building a data science project in maybe NLP, right? So natural language processing is one application. If you want to use that, if you want to build something like that, there is a requirement that you need to know how to write codes using a very specific libraries, right? So again, they are supporting your particular programming language itself, but it's very necessary, it's absolutely necessary that you need to know how to write the codes in them, okay? So that's why I have put it over there, learning the different tools. For example, I can go one step ahead and I can tell the tools names also, right? And for machine learning, if you want to build, you can start with something called as sklearn, scikit-learn. That's one tool. Then you can go one step ahead and you can learn, say, TensorFlow built by Google. Then you can use Keras. Those are the supportive tools in Python, which are going to be used for specific applications. Like I want to build something related to ML, DL. These are the widely used tools. Even industry is using same thing these days. All right, so the last aspect, as you can see, you do a real-time project where you start from very basic stuff, from collecting the data set, you do the cleaning of data engineering, then build different models, train them, then perform a testing on them, get the results, and you decide what to do further. Okay, so this is a very basic thing. This is the starting point. All right, so this is the whole goal of what we are going to discuss today. So let's start with the very basic concept. So nowadays we have, I think in your curriculum you have a lab session, right? So in labs also you do the coding, right? So a question is given to you, you do a coding and you try to solve a problem. So one such very simple program is, take your own language, whichever programming language you are comfortable with, you'll write a code. So the question could be something like, I will input a temperature in degrees Celsius and I want you to convert that into a Fahrenheit. All right. So if that is a question, right, it's called as a classical programming. It's not ML. There is no machine learning, because even ML we are trying to do the coding itself, right? But it's called as a classical way of doing the program. So why it is called as classical programming? Because I'll give the input data, that's the degree Celsius which I want to convert into Fahrenheit. In addition to that, I will also give an input saying that, okay, use this rule. What's that rule? You can see that. So F equal to 9 by 5c plus a constant. So I'm going to tell machine that use this formula, this equation. Any c is given, put it over there. What answer you get as F, you give it as output. So you can write this program in any possible way, right? So that's a classical way of doing the programming. All right, now let's look at the difference between this and ML. How ML is different? Because over there also you may think that yes, machine is learning about that equation and it's giving an output, right? So now you see the difference. Let me make the statement different for the machine. Now I'm going to give the input, and these inputs, I'm not going to give the rule, I'm not giving the formula to the machine. I'm going to give an input saying that, look at the first column. So it says these are the Celsius values, and I'm going to give this answers to the machine saying that these are the expected answers. For example, it's like saying when I give 34 as input, expected output is 93.2. Like that. So you see, 35 is given, 95 is expected, like that. I give a set of inputs and set of values which are the expected outputs. All right. Now you see, during this what happens, since I'm not giving any equation which relates this is X, we call this is input, this is the output. We are not specifying for a given input, how do you find the output? We are not specifying. Okay, so what happens now? What's the question to the machine? Machine has to find out this rule. So F equal to 9 by 5c plus 32. Now it's a challenge to the machine to find that. Okay, so the requirement is that machine needs to understand that, okay, this is how I relate these two numbers. So I give this as C, 9 by 5c plus 32 is this answer. Now machine has to find out. Now you see the difference, right? So classical programming is rule based. I give the rule plus data. But in case of machine learning, the very fundamental difference is that no rules will be given to the machine. You will give data itself. It's a data driven. So I give the data, what is my input, what is my output. Machine has to understand how do you relate those two. So this is more evident. Maybe this looks very simple for us. Maybe you just have to fit a straight line, because y equal to mx plus c is a straight line. So we know how to fit straight lines. Mathematics already discusses that. Now take the questions to the next level. Let me say my problem is a image classification. So 4 categories: dog, cat, table, chair. Now when I train the machine, so the table which you see here is training. There are 2 phases of ML. One is training, one is testing. So during the training, I do this. I say this is the input, this is the expected output, machine learns. And during the testing phase, what we do, I give only this, no y. Y is not there. Machine has to tell that, okay, if this is the input, this is the output, machine has to predict. So same question when it comes to the classification algorithms such as image classification, object recognition, etc. You see that a whole data set is given, that is a table, chair or dog, cat, etc. Now the output y will be the name of the class. This image cat, this image dog, like that. So you see there is a lot of complexity because you are not passing a single number, you are passing a big matrix. Matrix can be of size 256 into 256, right? So colors will vary, intensity will vary, right? The brightness of the image changes, etc. There are a lot of information that is available, and as this information is passed to the machine along with the labels, you are trying to make sure that machine learns how to identify those. Okay, so that's the very simple difference compared to the classical programming. All right, I think I can go ahead. We are fine with this. Now, the very first approach of ML was done in 1950 by a scientist called Arthur Samuel, 1959. So the original idea of, okay, we can do something like this and we can teach machines so that what you call as the ML can be implemented. This is what was the very first scenario. Okay. Now, there are various terms that we hear these days associated with ML. So those words are, I want to differentiate so that whenever you encounter these words here onwards, there should not be any confusion. So that, let's see. So you see this green circle, which is outermost circle, largest circle, it's a data science. So data science basically deals with many other aspects as well. We'll look at one by one. So on the left hand side, what you see is the AI, which is the artificial intelligence. Now, if you say what is artificial intelligence, it's like you are trying to bring the intelligence into machine. What is intelligence? We'll see that. It's basically decision making process. How do you teach machines to take a right decision at the right time? So that's what is all about the AI. And we have huge amount of data that is available, right? So that actually encounters this data science. And inside this data science, you can see that there is another circle, which actually the intersection of data science and AI, that's ML, that's the machine learning, right? So now you should be able to relate them. I want to build a artificially intelligent machine. I have enough data, but the bounding between these two can be achieved by using the ML techniques. Okay, so that's what is ML. Now I have other components, right? So problem formulation. Now the problem formulation is basically on the business side. So a tech giant like Google will say that I want to double my subscribers in next 2 years. So what you are supposed to do, you use the data set what they have, you see which user is buying what, right? A product at the particular time, a trend analysis is what basically they do, and they will try to understand, right, a business problem. Then you see the word data engineering, IoT, right? Different sensors, visualization, etc. come under the data hood itself. Okay. Now you see here you can see another circle. I think that may not be visible because I chose a wrong color mostly. So there is something called as NN. All right. NN stands for neural networks. And if you observe very carefully, there is another circle over here inside this circle, which is big data. So there is big data, right? I'll come to the big data later. Let's try to identify what is this big data. So this big data, so between this big data and neural networks, there is another connection that's written in the small letters. It's actually DL, stands for deep learning. Now, the deep learning is, again, if you see very carefully, this is inside the ML itself. Inside the ML, I have neural network. Inside that, I have DL, which actually relates to the big data. Now, if you think carefully, you will understand one very important concept. That's the need of DL. Why do you need deep learning? Because whenever we say that ML can solve each and every problem, almost every problem in the world you can try to solve. If you have enough data set, machines can be trained and machines will be able to solve that. But now the question is, then why do you need this, something which is called as a deep learning? Again, deep learning has not evolved completely. Deep learning is still in the research process. Some of the applications we are using deep learning, whichever algorithms they are giving satisfactory results, we are using them. Okay, so we can answer that question by looking at this concept. So there is something called as big data, and this deep learning is inside the big data. So one thing we should be able to relate now is that, okay, when it comes to the big data, maybe ML cannot solve, so you need something called as a DL. All right, so that's the concept. I'll come to that later, right? So these are the widely used terms. So again, we'll go back to the very basic point of data. Right? So everything starts from data. You have to collect the data. Data should be very clear. Only then machines can learn. Now there is a very important concept which actually separates information from the data. So you need to provide information to the machine rather than the data set. That's why the whole data engineering was our very first step. right? This is very important because take this example. This example, assume that you are watching a cricket match and Virat Kohli comes to the bat and the TV channel shows this. Okay? Virat Kohli scores in the innings of ODI, right? Is it of any use? It's of no use to us. What we expect? We expect this. Correct? That's what makes sense, right? I understand that, okay, this was his average, these many hundreds he has scored. Everything is directly visible. That's information. This is the data, right? This data is of no use to me. I don't understand anything. It's actually, if you look carefully, it says that which is the venue of all last 100 matches, every venue, who was the opponent, every name, if it is visible to us, it's just a data, right? It's of no use to you. What you want is, you want something like this. He played this to this, these many matches, this is the run, this is the highest run, this is the average, so many hundreds. That's what? That's information, right? So we want information to be given to the machine. So conversion of this data set which we normally collect from various sensors or from websites or from anywhere, right? Converting the data set into information is pretty much important, right? So we need to do that. So this process actually begins from there. You collect the data set, modify your data in such a way that you get only the required information. You retain only the required information so that you can process further. You can build the models. So we'll go to the modeling slightly later. So whenever I want to perform this conversion, that's from data set to the information so that I can build a model. We can perform 4 different types of analysis on the data set which we collect. So this is the data engineering part of which actually happens before the ML or DL. So you can see the very first analysis that we try to perform on the data is called as a descriptive analysis. Right? So descriptive analysis is a part where we try to ask a question that what happened? What happened could be something like how many hundreds he has scored. What happened? You just look at the data, you answer the questions. Right? So it's a very straightforward way of analyzing the data set you have. So you can see that what happened. Normally what tools we require is just a summary of statistics, histograms. So you can see the mathematical aspects that is required in reality. So if you want to do this kind of analysis, it is highly suggested that you will use statistics, data visualization, metrics. So I already mentioned that our very foundational step includes the mathematics as well as the basic programming. So let's go to the next analysis part, which is called as diagnostic analysis. Now the question is slightly changed. You will try to answer the question why it happened. Possible question could be why he scored 0 in the last match. So why it happened is a question. Maybe now you need little bit of more analysis, and this analysis includes who is the opponent. Oh, okay, maybe with Sri Lanka his performance is not good. I don't know, sorry. If you are pure cricketer, excuse me. So this is how. So maybe this is the opponent and this is the bowler. This is the pitch condition. You see, you do analysis in a different way to answer that question. So the first analysis we did, right, has nothing to do with this kind of analysis. So you see that it's a diagnostic analysis. So we try to perform the same thing using correlation, covariance, entropy, mutual information. Those are the key aspects coming from mathematics in understanding this whole concept. All right, so that's the probability statistics coming into picture. Next is predictive analysis. Now this is where the probability slightly enters into field. What is the possible score he's going to make in the next match? So this is a prediction, right? So you see, you need probability calculus, matrix algebra, right? This is not straightforward. You cannot do using any of the basic statistic tools. You need to go to ML models, time series models, to do these kind of analysis. Again, going to the last type of analysis that you can perform is called as a prescriptive analysis, in which I know what I want to achieve, right? What is the steps that are supposed to be taken to achieve that step? For example, I have this much money, right? And I want to say that, make a formula, I want to form a problem saying that in the next 1 year, I want to double this amount. That's my target. You see, I know what I want to do. The prescription needs to be given by machine. Machine should say that invest 20% in gold, 30% in real estate, remaining amount, put it into this like that. You see, the prescription needs to be given by the machine, right? So that is what is going to happen in the prescriptive analysis. So again, it's a data-driven model. You have to give the data set, very proper data set for this, so that machines can learn and give you an answer. All right, so that's what is happening in the prescriptive analysis, and you can see that we need probability calculus. MLDL models are very important. So out of which very simple analysis like the first two you can do with what mathematics we already know, you can apply and you can do that. But when it comes to the complex questions like the last two, predictive and prescriptive, you need ML. That's where the ML comes into picture. Okay, so next, let's try to discuss some of the very basic terms related to the ML. These terms will be carried even for the further topics like neural networks, deep learning, and applications including business analytics, etc. These are the common terms which are widely used. So one is called as a label. Label is the data, right? The X, which we were discussing earlier, it can be one column, it can be multiple columns. All right, that's the data set. We call it as a label. Then you have a, I told reverse. Label is the output, my mistake. So the final column which says that, okay, this is the expected output is called as a label or target. Normally, Y is the name for that. All right, we have another one which is the feature. It is X. It actually is going to help the machine to make the prediction, how to get the Y from X. That X is the features, all right? Then you do what is called as a feature in engineering. Just to tell in brief about the feature engineering, let's say we have so many columns in my data set. The X has, say, 100 columns, okay? And Y is, say, maybe I'll give an example. There is a patient data set, let's assume. So patient who is getting operated, the data set contains what is his blood pressure, what is sugar level, right, etc. Many tests are performed and there is a data set. Every column represents one feature. And finally, one column says whether the patient survived or he passed away. So 0 or 1, that's your Y. You need to predict that by looking at all these X values. All right. So let's say in that scenario, if you have 100 or 150 columns, it becomes very hard for machines to understand that data. So what we do, we try to reduce, right? Maybe some of the test results have nothing to do with whether the patient survived or not. So what you do, you can eliminate. If you are an expert, you can definitely do but we need to know a little bit of medical history to that. Most of the times, those who develop these technologies are not doctors, right? So it means we can reduce it by using ML techniques once again. So you need to use some of the machine learning techniques so that you reduce the 100 columns of your data into, say, 20, 25. So you reduce the features. So this is one of the very important aspects. So that is what is going to happen in feature engineering. So you do some transformation and you reduce your data size. Then one of the very other common term is the dimensionality. So this has something to do with my previous example. So if you have number of features, if you have so many number of columns in your data set, every column is a dimension, right? If you have 3 columns in your data set, it's a 3D data, 3-dimensional data. Like XYZ coordinates makes 3 dimension, correct? So you are aware of that, I guess. Like that. So more number of columns you have means your data set is more complex. So humans can understand and visualize up to 3 dimensions. I can see, but fourth dimension, I don't know how to plot it. I don't know how to visualize that. Like that, machines can understand easily up to, say, 10 dimensions. But if you increase your columns to, say, 250, it becomes a mess. Right? So it's always expected that you try to reduce the number of columns. So the dimensionality is pretty much important. That's another term which comes into picture. And one more very important term is the weight. It's called as a model's parameter. Whenever I train different machine learning models, model tries to understand the problem in terms of these weights, right? So it's a model's parameter. If you, for example, if you take a straight line, what are the parameters of a straight line? The slope is a parameter. The y-intercept is a parameter. So if you write y equal to mx plus c, you know that m is a parameter. M and c, if you know, you can draw a straight line. Correct? So like that. So if you know the parameters of a model, models can understand how to classify the given problem. All right, so those are the very important terms. Okay, so far we understood roughly what is all about ML. What type of programming we do, what type of data set we need, what machines do, etc. we know. Now let's go one step ahead and let's try to look at the complexity. So this one particular slide actually explains the different types of problems that machine learning algorithms can solve, and also there are some examples given over there which are the different domains where these kind of ML can be applied. So the first one is called as supervised learning. So supervised learning is something wherein I try to give the machine what is my data and what is the label. Data in the sense, it can be the 4 different classes of images I mentioned, like cat, dog, table, chair. And along with each of the image, I will also specify, okay, this image is a chair, this image is a cat, this image is a dog. So I'm giving the label. In the sense, I'm giving the right answers. If this is the asked question, you need to answer this. If the next question is a dog, you need to give an output saying that it is a dog, like that. You see, I'm giving the machine data set plus the labels. All right. If I give that during the training, right, that kind of problems fall under the first category, which is the supervised learning. Right. In supervised learning, basically we can try to solve 2 different kinds of subcategories. First one is called as a classification. Second one is called as a regression. So what is classification? Take the example which we discussed now, right? So 4 different classes of images given. Any image given, machine needs to say, okay, this belongs to this class, this belongs to the other class, like that. Classification is one problem. So that is what is happening over here. Maybe the examples, image classification, customers classification, etc. are the examples, major problems which we can solve. You can see another one which is a regression. In regression, the output variable is going to be a continuous number. So look at the previous problem of classification. Output is a discrete number. Output is discrete in the sense cat is 0, dog is 1, say table is 2, and chair is 3. So 0, 1, 2, 3. You see there is no 0.5. There is no 1.5. It's a discrete number. So if you have that kind of problem, so your problem falls under the first case, that is classification. So if the number that you are trying to predict is a continuous number, the rainfall, it can be 11.333. You see, there is no restriction that after 11 it has to be 12, right? You can have a continuous number, continuous real number possible over there. So any such scenario that falls under next case, that is a regression. So stock market prediction, etc. The prediction of average height of a student in a class, right? All these are regression problems, okay? So you can see various examples mentioned over there. Forecasting the market, right? How many number of advertisements, right, should be shown for this region of a country so that I can double my market, etc. are going to be falling under this. So that's the first part, supervised learning, where there is a supervision. Supervision in the sense you give that this is a question, this is the expected answer, you tell. During the training, you teach machine, supervise. Next case is, say this, it's unsupervised. In case of unsupervised, there is no right answers given to the machine. I'll just give the question, right? And the machine has to do the job by itself. There is no right answers given to the machine. So for example this is very widely used in case of a problem called clustering and another problem called dimensionality reduction. So there are 2 scenarios. Clustering is a major issue in most of the data science problems, wherein I have no idea how many classes are there in the data set. I have collected the data set, but I don't know how many classes are there. Right? Look at the previous scenario. In supervised, you know how many classes are there. You say that, okay, I have images of 4 classes, cat, dog, etc., so and so. But now you don't know. In such scenario, you can ask machine to say that, okay, go through all these data sets and tell me how many classes are there in this data set. Machine can group them into several classes and give you the answer. So that is a very widely used application. It's falling under clustering. You are asking machine to give me the answer, how many clusters are there. Okay, and one more is this, it's a dimensionality reduction. Already we have discussed once about this. If you have too many number of features, too many dimensions in your data set, you can reduce them. Okay, so that reduction is definitely going to happen through, again by using the ML algorithms, separate algorithms which can actually implement the same. All right, so that's what is happening here. And then we have the reinforcement learning. This is again slightly advanced topic, and we don't have many applications that are running over here, because in this particular concept of reinforcement learning, they are trying to eliminate the concept of training. So far we understood that I teach the machine that, okay, this is this class, this is like this, I teach, right? Now the training part has to be eliminated completely, because normally what we see is that training takes huge amount of time. There are algorithms, ML algorithms, which run for months together to train, right? I have, say, so there is no training associated with that, with the child when it tries to learn how to walk. So that's how the human brain's evolution works. So you see that child stands, maybe one step, it falls. Then it understands, okay, I should not do that, so that next step maybe it's a correct step, like that. You see, directly the testing procedure begins, no training. So there is no requirement of training. Without training also, you can build some models which actually starts with the testing. It makes wrong decisions, then it learns. So this concept of building ML model is what is going to happen in this reinforcement learning. One such example which you see there, I think its text is not visible, but still the game development is one of the very key application of reinforcement learning. So you try to teach machine how to play board games, maybe chess or something like that, right? By directly starting with playing, right? You don't teach that, okay, if opponent plays this step, you have to play this step. No, there is no, right? That's not given to the machine. Machine learns automatically. All right, so that's the key point. Again, the ultimate application can lead to up to maybe autonomous driving vehicles can also be built by using the same concept, where initially it may not be very successful, but on a long term, definitely this is a very promising application. Okay, so let's quickly look at the supervised and unsupervised. So supervised, you give the labels to the machines, that's the difference. In unsupervised, you don't give a label, you directly say that, okay, this is the data set and give me the number of classes or reduce the number of columns in the data, etc. Okay, so let's move further. Take an example of a supervised learning. This is a very simple example. Normal problems will not be this simple. So just look at this. So I have a data set and I want to understand that what's going to happen next. If you want to make this, it can be a regression. Regression problem is one type of unsupervised case where you see here so this is the data set from a real estate, where depending upon the parameters of a house price needs to be calculated, needs to be predicted. So you see these are the X values, number of bedrooms, right, square foots, age of the building, etc. So those are the features. If these are given, you are supposed to predict, okay, this is the price of the house, right? So one such case is that you see you are trying to plot the price versus square foot. Again, just to keep it simple, it's a one-dimensional data set is being used. I'm using only one column. But actually what machine learns is it uses all the three values and it tries to predict. So in order to understand how this happens, maybe this could be as simple as predicting a straight line. Try to fit a straight line for the given data, and I say that, okay, what if the square foot is 3,500, so it comes to the 3,500, it observes what is the point that is on the line, and that value will be read over here saying that, okay, that's the price. So now in this case, the problem is machine has to fit this straight line, that's all, right? In this case, it is very simple, but when it becomes, when you go to 3D, 4D or 5D or much higher dimension, it's not going to be a straight line. It has to understand what is the hyperplane. So that's the complexity. Okay, so that's the supervised regression. Same, if you want to do a classification, I give an example of image classification, but see this is much easier. So depending upon different parameters, I have stars or not star. It's a binary classification. So it will rain, it will not rain, like that. Okay, so you see, you will, again, machine has to fit, in this case, only a straight line, but that straight line should be clearly separating your classes. You are not going to make a prediction, you are just going to say that, okay, if this data set is given, it is a star. Anything falling on the right side of this is not a star. Okay, so this is what is the target in front of the machine, and machine learns in terms of the parameters, and there is a chance of error. Okay, always expected, right? Because we are not giving all the possibilities to the machine for during the training, so there is a chance of error. All right. Then, okay, this is the clustering and unsupervised learning part. In case of this unsupervised learning, I have no idea how many groups are there in this data. So you see here, data sets are plotted as it is, right? So every value of x and y, we have plotted the data, but I don't know. I don't know how many classes are there in this. I can ask machine, and machine can say that, yes, in your data set, we have 3 classes, and for each of the class, machine can give a different color. Okay? So this is the clustering problem. Again, we can solve them by using ML techniques. Okay, now we come to the intelligence part. It's one of the biggest question. How do you bring intelligence into machine, right? So intelligence has very important concepts, like you should be able to classify, reason, learn, predict, decide, manage and plan. These are the fundamental concepts that needs to be enabled in a machine, so that you can say that, okay, machine is artificially intelligent, right? So how to achieve this is a big question now. So I think you are familiar with these movies, right? So we know that what artificial intelligence is expected to be, right? Any movie you see that, okay, there is artificial intelligence, again, right? Is it real? Has it been achieved in any part so far? No. Okay, so, but in order to achieve this, what you need, we need data, we need algorithms, we need mathematics, we need programming, we need computational resources. Right now we have everything, right? So, one more example is the comparison between the data that we have, right? In 60 seconds in 2019, whatever data that was getting collected by each of them, you can see actually, we have Instagram over here, we have different chat tools, etc. Everything is available here. Whatever data set was being collected in 2019, in 2021, that is actually more than 100 times. 60 seconds data set itself is more than 100 times of what was being collected by them. Now you think in 2023, what is the current rate? So much data is available. That's the key aspect behind each business problem these days. Everybody wants to use this data which they have collected to build a model, and they can solve a business problem. This is the fundamental idea. All right, so let's look at the complete cycle of ML. So everything, as just now I discussed, everything starts with a business problem. So every tech giant has a vision in front of them, saying that, okay, I want to double my customers in next 2 years maybe. So that actually is the business problem. That's where everything starts. So convert this business problem into a ML problem. In the sense, what machine has to be done, has to do, you need to think about that. So that conversion is what we call as ML, machine learning problem. Then we have the data processing, very initial step if you remember. So you need to do the right away collection of the data set to modifying the data set so that you can train a model. That's the step number 1. Okay. Then you build the model. Model building uses training, testing, evaluation. Evaluation is pretty much necessary because when you say machine has learned something, I need to test that to understand, okay, how good it has learned. The same testing procedure. I teach my students, at the end there is an evaluation. There is a test that's going to happen. They have to clear with at least say 60-70% of marks to clear. That's the same thing, right? So there is expectation, evaluation that's present over here. So once this is done, we'll have to take a decision saying that did your needs are going to be met using this. If no, go back, right? Sorry, if it is no, you go back. Maybe you have to collect more data, do the training again, and then do the evaluation once again. If it is yes, you will deploy. Now, the current trend industry uses is deployment is not on a simple machine, deploy on a cloud. That's why the industry 4.0 is using one of the key aspect as cloud. So all this training testing can be done on your machine, no problem. But ultimate application needs to be put up in cloud so that using different apps, data set can go to directly onto your cloud. Cloud will perform the classification, regression, or whatever it is. So that's where the IoT and cloud comes into picture. That's here, all right. And one more advantage is that during this whole process of utilization of the cloud platform, you can collect the data set on a daily basis. New customer comes and uses your app means you get a new data. You can use that data for training once again. So you see here, deployment is done. There is a new data. You can once again do the training. You see this comes here, trains, it updates the model. That's what is happening in the chat GPT, correct? So you ask a question, you use a new question, or you give some new data to the machine, it actually on the background it updates the chat GPT, right? So the way in which you communicate with the machine, next time it tries to produce the answer in the same way how you frame the question. Similar words will be coming in the answer. If you observe, this is very evident. So that's where the cloud is being used in this part. Cloud plus IoT. IoT is required so that you send your data from your edge device to the cloud. Okay? Then, this is pretty much important. If you want to look at what are the tech stacks, in a sense, I understood what is happening in the ML, in the background, in the foreground, etc. Everything you know now. But if you want to deploy this, what are the tools that are important? This is the answer. So just see here. So step number 1 is look at your need, you form the problem, fine. So once this is done, now basically the data handling, I collected the data, I want to refine my data so that machines can learn something from this, means it is expected that you will be using pandas. It's one of the library in Python. Also you use NumPy. This Seaborn and Matplotlib are used for data visualization, because when I say that I have cleaned my data, I should be able to see that. So to visualize, you need some of the tools like Matplotlib, Seaborn. Then you need some of the pre-processing techniques which are directly available in some of the tools such as sklearn pre-processing. You can perform the imputation, right? Transformers, etc. can be used. Even the Spark is very widely used even in the industry. So this is what is required for the data handling part. Then you can build different models. So model building, you can get the help from, again, sklearn. You can also use the TF2, stands for TensorFlow, built by Google. Then you have Keras. Okay, these are the tools which you need to learn if you want to build ultimate tools or ultimate classification regression algorithms in ML or DL. Okay, then going further, you can fine tune the model. Once the model is built, maybe you want to make certain small changes in them so that it can increase your accuracy, right? So in order to achieve that, this is what is the requirement. So the tools could be Ensemble, voting classifiers, etc. Again, that are present inside the tool called sklearn. You can always use TensorFlow and Keras, PyTorch, etc. also for the same purpose. All right, then comes the presentation of, this is again a business view of that. So the technology actually stops over there. So this is our job. Then for every business need, there is always, the client comes into picture, you have to show that, okay, demonstrate something to them. For that purpose, we have presentation part. PowerPoint is obvious. This is what we discuss. Okay, we have various tools. These two are the tools which I highly recommend. One is called as Tableau, very important, and one more is called as Power BI. So those two are the tools widely used even in industry for presenting your work. Whatever work you have been carried out so far, just I want to display the results to some clients, right? You need those tools, right? Only visualization tools. It may look very simple, okay, what is there in visualization? But it's a 100 crore business, think about that. So each industry, each company is more than 100 crore. Right, per year. Okay, then yes, the last part comes, you need to deploy it over there. So we have Amazon working on the same thing. Amazon provides you the cloud services, Google provides, Microsoft provides, anything you want, you can use them to deploy. So once all these steps are completed, so these are the technical aspects of the same previous slide. So we just discussed what is happening over there. Now we saw, if you want to achieve them, what are the different tools that you need to know. Okay, I'll slightly go ahead. Okay, these are the normal problems that we face. So when you collect the data, we have observed that all the classes you will not get equal number of data points. For example, this is actually a practical case collected from the reviews given in Amazon. So you can see that most of the people have given 5 stars. The 1, 2, 3 star ratings of a particular product, you get very less reviews. So if you want to build a system which actually says that whether this review is 1-star review, 2-star review, or I want to give an input saying that, okay, this mobile phone is very good, right? But there are some issues like this. It has to generate a number for my text. It's a NLP task. So if I want to build something like this, you will face a problem that always most of the time, whenever it sees a good or some keywords like that, it directly gives a 5-star to that, because you see that during the training I gave more 5-star reviews than 1, 2 and 3. This is a problem. Data imbalance. Data is not balanced, right? So this is one very important problem that we see in most of the ML processes. Okay, so how do you address them? One solution is upsampling, right? Whatever data, so if you have 5-star reviews of 1000 and other classes you have very less, repeat them, right? You make copies of them so that every class becomes 1000, so that even the 5-star ratings are 1000, other classes are also 1000, which are repeated, no problem, machine can learn from that. That's one thing. Otherwise, whatever is highest, you cut it down. That's not suggested, but yes, we can go with that. Okay, that's called as a downsampling. And you can generate synthetic data, that's a data generation, and you can even give weights to that. Whatever is less, that has more weights. Whatever reviews you have highest, give less weightage to that. That's another approach. Okay, now one more very important aspect comes into picture. It's like, it's called as a cross-validation. In the whole process of machine learning, there is an important aspect called training. And this is what happens when we teach, right? I teach for 20 minutes and I ask a question, saying that whether I get a right answer or not gives me a hint that whether everyone is following or not. All right? Same thing can be applied to the machine learning, right? I have 10,000 data points to train, but every 100 data points I ask a question. I train a machine for 100 data points, I ask a question saying that, okay, classify this, right? So this is the procedure, so that you can keep track of what machine is learning. All right, so this process is what is called as the validation, basically cross-validation. For that, again, you need another data point, right? So because questions needs to be framed. So what we normally do, I have my completed data set, 10,000 images maybe. What I do, I divide them into training and testing data set initially. Normally, the general split will be 80-20, 75-25 can work. Now, what happens here, test data set is completely kept as separate. You will never use them until you enter into the phase of testing. Okay, now for this validation data, what we do, we have the training data, which is actually huge, 80%. Take a small piece of that, like 5% or 10% of this is what you try to separate. Okay? Out of this, whenever the training happens for certain duration, pick one question from the validation data set and ask a question. If it's right, you know it's going in the right direction. If it is wrong, you have to change your approach of training. This is what happens in ML. All right? Okay, let me go further. Yeah, so this is an example. This is a demo. So I have this yellow colored part is the training data set. You see here, this small piece of my training data set is validation. The remaining is a test data. Okay, so that's what is happening, but I will go further. Now, people from Google, they have done a research and they suggested a new way. Because if you have 10,000 images and out of which if you take a part of it for validation, your training curve becomes, it's not going to learn as much as you expect, right? So what they did, they introduced a concept called as k-fold cross validation, right? This is actually very efficient. It can be applied for any data set that you have. How the machine learns effectively here, because it's like you have a training data set. If you say k value equal to 5, divide your whole data set into 5 pieces. Piece number 1, 2, 3, 4, 5. Okay, now I have 5 pieces of my original data, training data only, testing data is separate. In that 5 pieces, you use the first 4 pieces for training, last piece for validation. Okay, this is done. Now you see, you don't stop here, you continue training. You further go ahead and use 1, 2, 3 and 5 for training. And the 4th piece will be used for validation. Now you see, you are doing the same procedure, but now you see, since this was not used for training in the previous case, machine learns more here because I'm using that data set, right? Again, since k is 5, there are 5 times increased computation. This actually increases the computational load on your machine. Machine needs more training here, more time is required to finish this job, but yes, this is more efficient. People have observed around 20% increase in the accuracy if you follow k-fold cross validation than simply using a validation data. Okay, so this is one key point I want to highlight. Okay, now let's say you have built different models. What are the names of different models? Which application? There is one summary slide which gives you the complete big picture, because so far I never used any of the specific algorithms name in ML. I'm coming to that. Okay, so now let's say we have done the training is complete. Now you need to evaluate whether the machine has learned properly or not. So if that is our goal, you may normally face one of the 3 scenarios here. The first scenario is called as underfitting. Underfitting in the sense, machine is not able to perform well in the test. During the testing phase, machine fails. Why? Because, assume that this is the data set. Machine tried to fit the most simple separation among the classes. Because if you see, what we expected is that somewhere here, right, because there is a star here, the curve is expected to go like this, and this. What is expected? A complex curve is expected, but machine tried to fit a very simple curve. So that is the reason why whenever this test sample is given, it says that this is not star, but it is actually a star. So same thing could happen for this data point and this data point. So it does not mean that machine cannot make any mistakes. Machines can make mistakes, but not mistakes like this. Okay, so machine needs to fit a complex curve so that it can separate them. That's what is expected. If the machine fits a very simple simple curve, then that is underfitting. Now you see, this is overfitting, right? Overfitting in the sense, look at the complexity of the curve. This is too complex. We don't expect this. Whenever machine tries to learn, it can make some mistakes. Now, sorry. Now you see here, Machine tried to learn each and every data point very clearly, but this is not a generalizing, because we want generalized results. Machine has to learn how to generalize. So what I mean by generalization, you see this is a complex curve, separates most of the data points, and yes, there are mistakes. This is what is expected. You don't want too complicated model like this. You don't want too simple model like this. Machine has to learn how to generalize things. All right. So one of the major problem we feel is overfitting. Machine tries to learn each and every point that you give as training data, but it fails to generalize. During the testing phase, performance is very poor. During the training, 90%, 95%, but during the testing, 25, 30%. That's because of what is called as overfitting. So these are the major issues with them, and I'll slightly move ahead. Okay, so this is the summary part, all right? So now let's say that you have a data set with you, you know the problem, but you don't know which algorithm to be selected, right, under ML. Now, let's say this is a question you ask. You will simply ask the question that, do you have in your data set the target, labels, as well as the complete data? Do you have the labels available with you? In the sense, for this data, this is the expected outcome. Do you have that? If the answer is yes, you move to this side, because the problem falls under supervised learning, because you can supervise the machine learning process. If you don't have, that falls under the other case, which we call as unsupervised learning. Now, in supervised, just ask another question, that whether your Y, the target, is it continuous or discrete? If it is continuous, it's a prediction, right? Like a stock market prediction. So that falls over here. It's a value. So the problem is a regression. You are supposed to choose one of the algorithm from here. All right. So you can see it's actually linear regression, decision tree regression, random forest. These are the names you should know, right? Because when you explore further, definitely you know what algorithm you need to consider. If you go to this particular part, these are the very famous algorithms. You can choose one of them. All right. So if the other option here, in the sense, if my target variable is discrete, cat or dog, it will rain today, it will not rain today, like that. Yes or no type of answer, or any classification, that falls under here. So classification algorithms names you can see, SVM, decision tree, random forest, artificial neural networks, etc. are very dominant technologies. Okay, so if in the very first part, if my answer was no, in the sense I don't have the labels available with me, I'll move to this side, and that actually falls under the unsupervised learning, where supervision is not possible. So you can ask questions like this. Do you have to reduce the dimensions, right? So if I have 100 columns and I want only 20 columns to be retained, so that's actually the dimensionality reduction problem. So you can see principal component analysis, etc. Many other techniques are available. You can select any one of them and reduce the number of columns. But if you don't know how many classes are there in your data set, the answer can be found by using the clustering. So k-means, db-scan, etc. are very widely used algorithms. Even Gaussian mixture models can be used. Then one more application which we never discussed earlier. This is about the anomaly detection, right? So there are many outliers present in your data set. You want to eliminate that? Yes, machine learning can help you to do that. It's anomaly detection. So you can see GMM, PCA, etc. can also be used over here for this purpose. Okay, I'll quickly go with some of the examples, very specific. One is the problem falls under what is called as a ranking algorithms, right? Where to rank different products, right, on your page. This can be done over here. Then the product recommendation, you purchase some of the items. Related items, the Amazon is going to give you that, okay, this is what is highly recommended to you because you purchased this. Then you can see the classification. Different types of dress materials can be classified. Again, it can be done automatically if you use ML techniques. Then the regression comes into picture. So here the prediction of the requirement. There is a festival season coming, means you can actually predict that, okay, this particular product, there may be a huge demand during this time. All right. Then Clustering, similar items can be clubbed together, right? That's what is a clustering about. Then anomaly detection, right? You can try to detect abnormalities in the data sets as well. So these are some of the widely used applications. Okay, I think I already have covered most of them. And we are open for questions. Yes, semi-supervised learning it actually involves, you can do semi-supervised learning whenever you have a data set which includes a part which is not labeled and another part of the same data set is labeled. I have both labeled as well as unlabeled data. So pure definition says if you have labeled, you have to do supervised. If you don't have any labeled data, you have to perform unsupervised. But there is a possibility of getting mixture of them. Whenever I collect the data, a part of the data I get supervised, labeled, another part of the data is unlabeled. In such cases, during the training we use labeled data, machine gets trained quickly. You use the unlabeled data for testing purpose. So this whole concept is what is called as semi-supervised learning. Okay.
Technical, but something like since first year students are there, I think most are the EAC students. So perhaps I don't know, but some things are very much technical, but for them you may not are not getting interested a little bit. So what I'm asking you, sir, is that so what is going to be their career in this field, and at this present situation in the first year itself, or maybe those who are in second year and all, if they start showing their interest, so to what extent they can go, how they can start learning this on their own, or maybe if suppose training session is done, how serious they have to be being an ENC students, because some things I think perhaps computer science or some other branch, but because in the morning when I spoke to you, you told that even civil branch students are learning machine learning nowadays, because industry, no matter which field, which department you are, almost all industries are training their employees in this direction. So how important is this for their career, even though they are from other departments, is what, because this is a YouTube live session, so I think many other departments, if anybody in future they watch, they will get an answer to this question. Yes.
That's actually a very important question to say. How important it is, in order to answer that, these days the requirement in the field of AI, ML, data science is too huge, all right? And we don't have sufficient number of candidates. That's the first thing, because nobody has learnt them. So they can say that I am from CSE, but they don't know this, right? Again, that's the first part. So everybody must learn, because industry is opening now. There are a lot of openings over there, but candidates don't know this, because it's not just programming, it's not just learning a particular technology. You might have already understood that. It involves many other components, like you should know mathematics, you should know different tools, you should be using the tools, right, such a way that you can solve any problem given over there. And the second aspect is that, yes, being ENC is actually something like there is actually a additive, you are actually to be lucky on this side, I would say, just because, think, CSE students don't know signal processing, right? But because most of the sensor related automotive field, if you see, everything is based on sensors. They don't know what is FFT. They have no idea how the fast Fourier transform works, but you have advantage. That's why this is the advantageous part, because you know what is, you don't have to learn from basic to how the Fourier transform works, how the Fourier series, where to apply Fourier series, where to apply Fourier transform. It's, the company has nothing to teach to you, because you know them. Just the coding part is what is that. That's why I said there is advantage on being circuit related branch side. This is what I observed when I teach industry side. So whenever somebody asks, I ask a question, what's your background? So most of the answers given to the real-time scenario, where to take FFT, etc., 2D FFT, 3D FFT, etc., comes into picture. I get answers only those who are coming from non-CS backgrounds. That's one part. And the second aspect is that doesn't matter which industry you go, every industry is using AI and ML these days. So that's why it is very important, it is must these days. And it's a expectation that mostly next 15 years, every industry will definitely use this. So you go to manufacturing industry, that's where the mostly the mechanical background candidates work. Everybody needs this these days. Then definitely all software companies are they're definitely using. So even if you go to software, there is a requirement. The biomedical industry is also using same thing. Almost all vehicle manufacturers are using them. Even the fintech banks, right? Maybe you have plans to apply for some banks for manager posts and exams and do that. So even banks are using them these days. So we get a lot of training requirements from different banks. All right. So nowadays the scenario is that doesn't matter which field you go, right? Whatever may be your career path for the next 15 years, it's absolutely necessary, right? So being on a circuit branch size gives you a lot of advantages, right? But still, everybody has to learn this. I think I answered that.
So, good. Sir, what kind of projects the students can start from the scratch about this machine learning? So they can build the career from if they're second year or third year, the easy projects they can take up with respect to machine learning.
So in each aspect, maybe it can be, so in order to do a project, there is a basic requirement like you need to know the basics of ML at least. Like ML requires something below this, already you know what they are. So once you have completed them, then normally you can choose any field of your interest. Like say once the ML is complete, normally we have in our training curriculum, we have multiple modules coming up where students can choose. Like I know up to ML, now I want to build some real-time application. You can choose something from NLP, natural language processing, very widely used these days. Take up any simple example like classification. You can take a Amazon review and you can say that, okay, if this review is given, is it a positive review? Is it a negative review? Very simple exam, very simple project, that's one thing. And another application is on the signal processing side, and maybe radar signal processing. You can build AI models, machine learning models to detect an object, right? That's the case. Most of the signal processing industry is using the same thing, okay? So even this radar is being used in ADAS, if you remember, if you know, right? Automatic driving assistance system. So whether you are departing from a line or not, etc., or whether a person is sleeping or not, right? During the driving, right? Driving assistance system. So in that, again, another component is a CV, computer vision. You can take a simple computer vision, like classifying the objects, right? Food category, right? Etc. can be done. Then the language modeling, speech recognition is another field. So a lot of work is being carried out on English and European language. Indian languages, we don't find any support. And yes, you can definitely choose anything over there, like Tulu. Sentiment analysis. Somebody is speaking, you want to say that whether he is happy, he is sad, like that. So that's another field. And even for the business analytics, you have the data set of a particular organization and you want to make some predictions, right? What will happen? How many number of admissions are going to happen for the next year for this institute? You can collect the last data and you can build the models to the prediction. So these are the very simple ones to start with. Okay, and once you are familiar with almost all concepts, because ML is not the end. After ML, you have neural networks, then you have deep learning, and many more things to come. Only, again, by the time you study that, there will be something new that will definitely come, because a lot of rigorous research is happening in the field of deep learning in Google and also in Microsoft. Because of that, some additional components are expected by the end of next year. I hope I answered the question. Yeah.
Sir, I want one clarification regarding that classification and regression. Can we apply the same model or same algorithm for both the fields, sir, for classification and regression also?
To answer that, answer is in two parts. For some of the models, there are restrictions, like linear regression. It's meant only for regression. If you want to apply that for classification, you have to slightly change the model and build a logistic regression, which can solve the classification. Whereas there are some algorithms such as decision tree, you can use for classification as well as regression. Okay, depends on which model specifically we are talking about. There are some models which can be used for both, some models which have restrictions, like that.
Thank you, sir. We are very thankful and grateful to Mr. Prashant for the power-packed information that he has provided today. I'm sure it was a great learning experience. I'm sure it was a great learning experience for all of us. And data science under the umbrella term with all the associated terms, AI, ML, DL, it was a kickstart for even the beginners of machine learning. So I'm very thankful and grateful to you, sir, for this informative session. Thank you, sir.
So this is a little bit personal thanks from my side also, because he was my MTech mate actually when we studied in MIT Manipal. Of course, from that time only I observed that he is a very dedicated fellow, because entire engineering Fourier transform you have learned. But one day when I was speaking to him in room, he literally told me what is Fourier transform in his own way. So that is where I just understood that to what level he's having an IQ, I can say. So anyway, the thing is, the best part about him is that he has started the training academy called as the Dharani Academy, and he has trained overseas many companies. Maybe it is US, or maybe for him it is every month going to Oman and Dubai is now very much casual. So that is why I want to thank him, especially that he found time to come here and give a talk to us. Straight away, he came from Bangalore, and now after this session, he's living to Bangalore again. So thank you very much personally for that. That is my honor that I was a part during MTech time. Thank you so much to our HOD also, and for giving this opportunity for us to get the chief guest here to our college. So thank you very much, all the faculties and also the students. Perhaps some students were a bit, not knowing the seriousness of this thing. We here in most of the time students get seriousness when they reach around third year, final year. But the trend has to change, that when you are in first year itself, you are on to these things, that what you want to do in life. I think perhaps that is where the success rate may be high. So thank you very much, and also to the coordinator, program coordinator Gauri Shegde, and all the staffs. Thank you once again. Thank you, Prashant.
Thank you. We will have a 10 minutes break, followed a 5 minutes break, followed by the second keynote address. Please join back quickly after a 5 minutes break. Tea will be served outside. Please have tea and join back after 5 minutes.